Hi everybody. In this video, we are going to be talking about 4.1.1, which is simplifying ratios and rates. So first, we're going to start with our definition of a ratio, and a ratio is used to compare amounts or quantities. It's also used to describe a relationship between two amounts or quantities. So for example, a ratio might be used to describe the cost of a month's rent compared to a monthly income. So maybe your rent is, maybe it's like rent per income. And again, we're talking about monthly, right? So maybe your portion of rent is like $250 per your income, which I hope would be more, would be something like $300. And so something like that. Again, because you're wanting to have extra because you still have lots of other things to pay for. And I get it. Sometimes when we're in college, we cannot even make much for income. And so you're having to go ahead and take out a loan or something. And so your monthly income would be more than that because you're factoring in your loan amount as well. Or if you're getting help from a grandparent or parent or something like that too. Okay, or you may use a ratio to compare the volume per cost of two different brands of shaving cream. And so I actually do this quite a lot at the grocery store, that I will look at different types of noodles or different types of milk or yogurt or something like that. And I might say, okay, well, I'm fine with both of these brands. I'm fine with the 2% milk, but which one is cheaper per cost? And so I might look at that as well. So how to write a ratio? We can write it in actually a few different ways. So here's our scenario that we're going to base our written form off of. It says for every 10 sugar cookies, I have 20 chocolate chip cookies. The ratio of sugar cookies to chocolate chip cookies can be written in three different ways. One thing you want to make sure you're keeping track of is that it's sugar cookies to chocolate chip cookies. So we're talking about sugar, which is going to be the 10 to 20 chocolate chip cookies. So one, we can just use the word to. So we can say it's a 10 to 20 ratio. We can write it as a fraction. This is how we most often do it in this class. So we can write it as it's a 10 to 20 relationship, or if we simplified it, it'd be a 1 to 2 relationship. But you don't say 1/2. It's a 1/2 relationship. We don't talk about that. We don't say it like that when we're talking about a ratio. When we're talking about a ratio, we would say it's a 1 to 2 relationship, or we write it with a colon. And so we would say it's a 10 to 20 ratio, or it's a 1 to 2 ratio or relationship. Other important pieces of information regarding ratios. One quantity in a ratio is often greater than the second quantity, like you saw there, the 10 to 20. However, you don't always have to write the ratio so that it has the lesser value first. You don't always have to do it 10 to 20. You just have to make sure that you're doing it, you're writing it consistently. So long as you keep the relationship consistent. Also, you've got to follow the directions. So like this one said, for sure, sugar cookies to chocolate chip cookies. If it had said the reverse, chocolate chip to sugar, all of these would have been reversed. We would have said, so if we were doing chocolate chip to sugar cookies, it would have been the reverse. It would have been 20 to 10, 20 to 10, or 2 to 1. Or it would be 20 to 10 or 2 to 1 relationship, like that, as long as it's just consistent. And again, following the directions. It says ratios can compare a part to a part or a part to a whole. Ratios are never written as mixed numbers, never ever. So remember, mixed numbers are like 2 and 1/2. We never ever write our ratios like that. So again, if that was our ratio, that would be a 5-to-2 relationship or a 5-to-2 relationship. We would never convert that into a mixed number. Okay, so number 1, Paul is comparing the amount of chocolate chips contained in different types of chocolate chip cookies. When he makes homemade chocolate chip cookies, he ensures that each cookie contains 10 chocolate chips. It sounds like Paul suffers from a little bit of OCD, which I can sympathize with. I can be a little OCD myself, where we're just making sure that things are just so, and we have the exact perfect amount of chocolate chips in every cookie. So when he actually goes and buys cookies, the brand he purchases, good job, Paul, averages 16 chocolate chips per cookie. That's my kind of guy right there. Lots of chocolate chips. And I'm sorry. Oh, I think I already read that part. He ensures that each cookie contains 10 chocolate chips when he's doing homemade. So we are supposed to write a simplified ratio. So there's that word simplified too, which means we're going to reduce it. So that means reduce. That expresses the amount of chocolate chips in store-bought compared to homemade. So the amount of store-bought compared to homemade. And does it say how we are supposed to express it, a simplified ratio? It does not. So we get to choose how we'd like to write it. So we can choose to write it like with a word, with a fraction, with a colon, just as long as we simplify it, your choice. And again, you've got to pay attention to store-bought versus homemade. So store-bought, what was it, 16? Yes, so 16 to 10. And then if we're simplifying it, it would be 8 to 5. Or you could write it like 8 to 5, or you could do 8 to 5. Any of those would be appropriate for you to use. The next one, it says, suppose a recipe for oatmeal takes 3 cups of oatmeal and 6 cups of water. So I'm just going to write that down. 3 cups of oats per 6 cups of water. How much oatmeal should be used to mix with 3 cups of water? So the question becomes, all right, I'm doing 3 cups of water. And some of you could look at this and say, oh, I'm just taking half of it. So 6, if I divide that by 2, gives me 3. So now we're going to divide this by 2. And then that's going to give me 1.5 cups of oats. So that's one way to do it. Another way to do it, I've had students ask me, well, can't I do cross multiplication? So I'm taking off the labels just for sake of time here for a moment. But so this was our ratio, right? This was our unknown up here, which is where this X is now. You can also do cross multiplication. So you can do 3 times 3 equals 6 times X, where we're going like this. And again, we can only do that when we've got a fraction and a fraction separated by an equal sign. So then you get 9 equals 6x, then you divide both sides by 6. And if you want, you can go ahead and reduce them, or you can say, well, that's going to be x equals 1 3/6 cups, which is going to give me 1 1/2 cups of oats. So you can do it that way too. So I just want to give you both methods there. All right, letter B. How much water should you use if you have 2 cups of oatmeal? Simplify the ratio. So again, go back up and say, well, what did we start with? Like, what's our master ingredient list? And it's a 1-to-2 ratio. So it's going to be 3 cups of oats to 6 cups of water. And it says how much water. So this time my X comes down here to where the water is, because I'm paying attention to where that is. This is the H2O. How much water should you use if you have 2 cups of oats? Well, this one to me is not as simple. It's not as like, oh, what do I multiply 3 by to get 2? Well, you may not know. And so on this one, I would definitely do some cross multiplication. So if we're going to cross multiply, we're going to get 6 times 2 equals 3x. And then we're going to get 12 here equals 3x. Then we're going to divide by 3, and then we get 4 equals x. And then we're going to get 4 cups of water. Now here's another method, and it's one that we talked about a little bit earlier. When I happened to mention that this is also a 1-to-2 ratio, we could have also simplified it to be like, well, this is 1 cup of oats per 2 cups of water. And then if we know that we are given 2 cups of oats, and then we're asked, well, how much water is that? Well, if we know that it's a 1-to-2 ratio, we could have also just said, well, what's 2 times 2? And that gives us 4 because it's a 1-to-2 ratio. So if we reduced 2 over 4, we would get back to 1/2, which is exactly right. Or you say, how do I get from 1 to this 2? And it's, well, 1 times 2 gives me 2. So 2 times 2 is going to give me 4. And so then your answer here would be 4 cups of water as well. So there's so many different ways that you guys can do this, and you guys might have picked a different way to do it, and that's also fine. All right, letter C. You guys should pause the video, see if you can figure out letter C, and then I'm going to work through it as well. And then you should keep going. Keep going and see if you can do number 3 on your own as well. And then come back, hit play on the video, watch me on hyperspeed to make sure you're getting all the right pieces. And make sure you have it all correct and all of the things that you're supposed to include in there. And then verify that you did it right. All right, so here we go. You are making oatmeal for a large group and your mixing bowl holds 12 cups. How much of each ingredient should you use to make the most oatmeal possible? So again, our limit is 12 cups. So one thing you might think about doing is say, okay, well, if I know I've got a 1-to-2 ratio, it's 1 cup of oats per 2 cups of water. How many cups is that total that's in my mixing bowl? Well, that's going to be 3 cups total, right? So think about batches. How many batches of oatmeal can I make to get me up to 12 cups total? Or you're thinking, what is the ratio that's going to get me to like a 1-to-2 ratio that's going to end up equaling 12? So let's find out. So one thing you can do is you can just start doing multiples, and you can say, well, if I do 2 cups of oats, that's going to be 4 cups. And then that's going to give me 6 cups total. Like I'm adding 4 into a 6. Okay, then I do 3 cups, and then that's going to be 6 cups. And then that's going to be 9 cups total. So I'm getting closer. And let's go ahead and keep going. So if I do 4 cups of water, and that's going to give me 8 cups of oats. I'm sorry, I just mixed that up. 4 cups of oats per 8 cups of water. And that gives me 12 cups total ingredients, which is exactly my limit. So this is the most I can make in my bowl when I'm doing a batch for this larger group. And my mixing bowl only holds 12 cups. So that's the most I can do in that bowl. Again, there are tons more ways you can do that problem. So if you did another way, but you still ended up with the 4 cups oats and 8 cups water, that's awesome. Good for you. Your method works as well. Okay, so a school wants to maintain a certain ratio, a certain student to teacher ratio. Oh my goodness. And that ratio is 9-to-1. How many teachers should they have for 27 students? So pay attention here. We're talking about 9-to-1 for the student to teacher. So 9 students per 1 teacher. And then the question is, if I have 27 students, how many teachers is that? Well, you can do your cross multiplication, or you can also just say, well, I see that 27 is a multiple of 9. And so 9 times 3 is going to give me 27, which means 1 times 3 is going to give me 3. So that would mean how many teachers? I should have 27 students per 3 teachers. or you can just write out 3 teachers in order to maintain that ratio. So then it says if a school wants to maintain a student to teacher ratio of at most 10:3 and it has 29 teachers. So this time we've got 10 students per 3 teachers. And then we are saying we've got 29 teachers per how many students? Well, this one may not be as easy. You might be like, well, 29 is not a multiple of 3. So let's do some cross multiplication and let's see what we get. So if I'm doing cross multiplication, 10 times 29 is going to give me 290 equals 3x. I'm going to put in my calculator 290 divided by 3. And I get out x equals 96.6 repeating. And again, think about what that means. That means we're going to end up having 90, which label was this? This was students. 96 2/3 students. 96 2/3 students. Okay, now let's go back because now we have to figure out, well, am I going to round down to 96 or am I going to round up to 97? So which one is it? This is our question mark right now, 96 or 97? Well, in order to figure that out, we've got to go back here and read the problem. It says, if the school wants to maintain a student to teacher ratio of at most 10:3 and has 29 teachers, how many students can they enroll? Well, if you enroll 97, one of those classes is going to be at 11. It's going to be like there are going to be 11 students in one of those classes. So that absolutely, we cannot do that. So we have to go down because we want at most a 10:3 ratio. So this one's going to be 96 students. If you have questions on that rounding portion, please, please, please reach out to me, ask me in class, ask me in office hours, send me a text, send me an email so that we can go over that more in case you have questions on that. And then let me flip the page here because we are going to the next page in the video. So far we've talked about ratios, and then we're going to talk about a special type of ratio, which is exactly our first blank. A special type of ratio used to describe a relationship between different units of measure, such as speed, wages, or prices. It's a comparison that provides information such as dollars per hour, feet per second, and the word per usually indicates that you are dealing with a rate. Okay, so that's the thing that we're going to be looking for. We're going to be looking for that word per because that is the kind of the indicating word that we're dealing with a rate instead. So here we go. It says a car can be described as traveling 60 miles per hour, or gas may be sold at $3 per gallon. So how can we write a rate? Well, it's really similar to what we did on the previous pages. It says the rate or ratio of buses to people can be written 3 different ways, just like before. But because we are looking at 2 different units of measure, we will also, or we must also, include the units. So that's something to pay attention to because that's something that we're definitely going to be looking for. That I'm like when you're working on your homework or something, and if we're talking about a specific rate, and again, it's got that word per in it, that typically means we're talking about 2 different units of measure, meaning like this, 60 miles per 1 hour. So we would say 60 miles per 1 hour, or it would be $3 per 1 gallon. And so we're looking for a label on each, right here, here's our label, on each of those units of measure. All right, so we can do it with words. So it would be 6 buses per 300 people. We can write it as a fraction. So it'd be 6 buses per 300 people. If you end up simplifying it, by the way, so if we simplified this, we take a 6 out of both of them, it would be 1 bus per 50 people. And then with a colon. So it would be 6 buses per 300 people. And again, you got to make sure you put your labels on there. Again, or if you're simplifying it, it would be 1 bus per 50 people. All right, so I encourage you again, pause the video, see if you can go ahead and do these next few examples on your own, and then come back and watch me on hyperspeed. Oh, and then I'm not sure what just happened there. And then we will make sure that way you can make sure that you did your problems correct. All right, so it says write the rate as a simplified fraction. We've got 8 phone lines for 36 employees. And again, it says write the rate, which means again for our rate, why the pen tool just messes with me. One moment, please. Are we gonna work now? Thank you for working. Okay. It says write the rate as a simplified fraction. So again, remember, we're putting our labels on there. We're putting our numbers in there, and then it says to write as a fraction and to also simplify it. So I'm going to say 8 phone lines per 36 employees. I'm so sorry for the terrible handwriting. It's not normally this horrible. But then we're going to simplify it. And so it looks like we can at least take out a 4, and let's see what happens if we can take out anything more. So if we take out a 4, we end up getting 2 phone lines, and it's going to be per 9 employees. And then that looks like that's as simplified as we can get it. So that's going to be our final answer. And then this one, it says, Anita rides her bike 18 blocks in 20 minutes. So 18 blocks per 20 minutes. Express her rate as a simplified fraction. So again, we're going to have that word per in there. So per, and then as again, we're simplified fraction. So it looks like we can reduce this. Let's take out a 2, and we're going to get 9 blocks per 10 minutes for that one. And then again, that's it, because that's all we're doing when we're reducing it. So she's traveling 9 blocks in 10 minutes. All right, so now we specifically talk about a very specific type of rate called a unit rate. And a unit rate compares a quantity. So let me write this in. A unit rate compares a quantity to 1 unit of measure. So that's like that example of 65 miles per 1 hour. That's actually a unit rate. So not only is this a rate, but this is specifically a unit rate because my denominator is 1. And that's exactly what I'm getting ready to write in here. The denominator of a unit rate will always be 1. So speed is often expressed as a unit rate for miles per hour. So if we have a car and it travels 330 miles in 5 hours, we are going to find the unit rate. So we're going to divide this by 5 and this by 5 because we're always going to divide by whatever that denominator is in order to get 1 in our denominator. And so once you divide that by 5, you should end up with 66 miles per 1 hour. Or if you want, you can write it as 66 miles per hour because that P stands for the fraction bar, that per hour. So either one of those is totally fine. A crowded subway train has 384 passengers distributed evenly among 6 cars. What is the unit rate of passengers per subway card? So that means passengers is going to go in the numerator per subway car, which is 6 cars, and 384 passengers. So again, what I'm going to do, I have no idea if 384 is divisible by 6 or not, but we can check it. It ends in a 4, so that's divisible by 2. And then to check to see if it's divisible by 3, remember we go 8, 9, 10, 11, 12, 13, 14, 15. Is 15 divisible by 3? Yes. So that means it's going to go in there evenly, which is nice. So we're going to do 384 divided by 6, and that's going to give us 64. So it's going to be 64 passengers per 1 subway car. And that is our unit rate. Again, it's a unit rate because our denominator is 1. So here's one I do a ton. I do this a ton when I'm grocery shopping. So it says Sammy is trying to decide between 2 brands of crackers. Which brand has the lower unit price? So unit price, again, you're thinking about how much does it cost per ounce. So cost per ounce, which means, again, if we're doing cost per ounce, it's going to be 224 divided by 8, and I'm putting my labels on there. And then this one's going to be 324 divided by 12. And now we're just going to do a little math. So I'm going to do 2.24 divided by 8, and that gives me, this one is going to be 0.28, so 28 cents per, oops, not 8 ounces, 1 ounce. Sorry about that. Per 1 ounce. And then this one, let's divide them both by 12. So 3.24 divided by 12, I'm dividing by the denominator, is going to be 0.27, so 27 cents per ounce. So which one has the lower unit price? Brand B is going to have the lower unit price. So brand B with 27 cents per ounce. And that's your final answer for that one. So let's flip. We've got one more example to try here. And again, if you haven't already paused the video, pause the video, try this one out, see if you can do it, and then watch me on hyperspeed and see how you did on it. So here we go. It says a shopper is comparing 2 packages of rice at the grocery store. We have a 10-pound package. I'm just going to make some notes. We've got a 10-pound package that costs $9.89. So $9.89. And then we've got a 2-pound package that's going to cost $1.90. And again, I put the cost up top because, again, we're doing price per pound, right? That's what we're going to end up doing. And it says, which package has the lower unit price and what is its unit price to the nearest cent? So we're going to figure out which one has the lower one and what is it. So I'm going to do $9.89. Well, and it's just dividing it by 10. So if we're dividing it by 10, that means it's just moving one place over, right? For your decimal. So like this. So our price would be 0.989 per 1 pound. And then it says to the nearest cent. So I need to round this. So this is going to be approximately 0.99 per 1 pound. And then you're taking that $1.90 and then you are dividing that by 2. And so if you're dividing that by 2, that should end up giving you 95 cents per 1 pound. So again, you're dividing this by 2 and you're dividing this by 2. And so you end up with 95 cents per pound. So the 2-pound bag actually has our lower unit price. And let's see which one of these numbers is also going to, or letters is going to be correct. So it says a 2-pound bag has a lower unit price of 95 cents per pound. Well, that's true. Let's see if there's any others that are true. The 10-pound bag has a lower unit price. That's wrong. The 10-pound bag has a lower unit price. That's also wrong. The 2-pound bag has a lower unit price, true, of $1.90 per 2 pounds. Well, that's not the unit price. That's the actual price, but that's not the unit price. So that one doesn't work either. So our only answer is letter A, that the 2-pound bag surprisingly has the lower unit price. And that's it for this video. Thanks for tuning in.